Hi, everybody. Welcome back. So before we get started, I just kind of want to recap yesterday and really stress the importance of this section, of this whole unit is what I mean. So yesterday, we learned a lot, right? We went through the difference of squares, which meant that difference was subtraction with two terms that could each be squared. Then we looked at factor by grouping, which we could recognize because it had the four terms. And then we also had some trinomials. So tri meaning three, like triangle, tricycle, right? So I had the three terms. So we did factoring trinomials yesterday. Now, if you did not really understand that whole video yesterday, I really want you to go back and just try it again. Really take some time to work through each of those examples. Let me know, please, what questions you have, because I do not want to lose you in any part of this unit. This unit is so important. Like I know a lot of times, well, some of the time in math, you can be like, oh, well, I didn't understand today's lesson, but I'll be fine the rest of the quarter. I'm telling you this not to scare you, but just because I really want to make sure that you pass this class, is that if you do not understand the things that we went over yesterday, it truly would be impossible to pass a class. And again, I don't say that to scare you. I just really want you to know this is not going to go away, okay? It's not one of those things where we tried it and maybe there's one question on the quiz, one question on the test, and you'll be fine the rest of the quarter. I've written this whole looking ahead thing just to show you this unit, what we're practicing is factoring. And here's the entire next unit, okay? So we're going to spend a couple weeks in factoring and then another couple weeks doing problems that look like this looking ahead problem that I've done. And so you can see what we're going to be doing in the next unit is totally dependent on what we're doing in this unit. And you can see all these things that we learned yesterday, right? Like, look at this. What do we call that? That's a difference of squares. So if you don't know how to do a difference of squares, this problem would be impossible to do in the next whole unit, okay? Not just the next section, but after our next exam, the next unit, this is what we're doing. Here you can see factoring. You'd have to break that apart into four elements. This one, again, you're going to have to factor. And then beyond that, then we're going to go through and we'll talk about how to cancel those things out. So it really is fun. It's a fun unit to do as long as you understand this factoring. So again, just please make sure that you understand all those things that we talked about yesterday. It is so important that I've just made today just additional practice, okay? So there'll be like two tiny little new things that aren't really a big deal. That I'm just going to kind of slip in to these examples. We're going to work through just 9 of these together. And then I have the next 3 days set aside to just do practice activities, which in the classes is awesome because you guys work and I can wander around and kind of give hints. Online, it's going to be a little bit more challenging just because it's going to be the worksheets and my solutions, and I'm going to depend on you to post your awesome questions in the discussion board so that I can help you out, okay? Because I really want every single student to pass, okay? So, are we ready? Let's do this, okay? So let's get all this stuff out of the way. You do not have to worry about that yet. Let's erase all that. So my first example, we're going to work through 9 of these. First example should look familiar, right? Because we're just practicing what we already did yesterday. So, is it a difference of squares? Nope, not a difference because not two terms that we can subtract. Is it factored by grouping? It is not. Okay, so let's go ahead and force it to be a factor by grouping. Do you remember how to do that? Break it into those 4 terms. Okay, so what we do, bring this guy out front, 3x squared. Because we're going to bust apart the middle term, so we'll just drop this plus 10 down. Okay, remember, this first term out front, that 3, that's our A, 17 is our B, and 10 is our C. So off to the side, we write A times C. 3 times 10 would be 30. B is 17. And again, if you're already at the point where you can find those two numbers that multiply to 30 and add to 17, awesome. You do not have to write out all the different possible factors, okay? Just jump straight to it. In fact, hopefully by the next few days after all of this practice that we're going to be doing, hopefully everybody can do that. Okay. So hopefully it comes like this one's not too bad. So hopefully ones like this, everybody will be able to do in the next few days. Okay. So, but if not, that's totally fine. Let's go ahead and write them all out. So I could do 1 and 30. I could do 2 and 15. It'll give me 30. I could do 3 and 10. 4 is not going to go in evenly. I could do 5 and 6. And then next would be 6, which would just take me back to the 5. So I have all possible ones. So do you see any of these that multiply to 30 that would add to 17? Sure, that 2 and 15, right? So I'm just going to bust apart that 17x. Now, we're just going to consider that as I'm going to put the 15x first plus 2x. Because 15x plus 2x is 17x. Why do you think I put the 15 first? Just because I'm thinking ahead, it's going to factor nicely with that 3, right? I'm going to be able to pull out that, and the 2 is going to go super clean with that 10. It's going to look beautiful. Okay. Now we have our 4 terms, and we want to try to figure out what to do next, right? So let's go ahead and do factor by grouping. So that means grouping our first 2. What do our first 2 have in common? 3x. What do we multiply 3x by to get 3x squared? An x. What do we multiply 3x by to get 15x? A positive 5. Now these next 2, what factor do they have in common? A 2. So we have plus 2. Don't forget to write this plus. A lot of people forget that for some reason. Okay, so that's really important to put that plus in there. Because without it, it means that you're telling me that you'd multiply all that stuff together and you wouldn't yet. Okay, that's going to be on your next step. Okay, so let's see where we're at. So now, what would I multiply 2 by to get that 2x? X. And I have 2 trying to get to 10. Multiply that by, that 5 is going to go there. Now, do they, all of this stuff here, have a common factor? That x plus 5, pull it out front. Now, I need to think of if I have x plus 5, and I'm trying to get to 3x plus 5, I'm going to multiply it by that 3x. I have x plus 5. I'm trying to get to 2 times the quantity x plus 5. I'm going to stick in that plus 2. Now, is everything factored completely? It is, so we're done. Awesome. Example 2, 2x squared minus 3x minus 9. Go ahead and hit pause, give this one a try. Come back when you're ready. All right, let's see how you did. So this is going to equal, I'm going to drop down my 2x squared, my minus 9, because I need to break apart that middle term. My a times c, a is 2, c is negative 9, so a times c is negative 18. B, the middle term, is negative 3. Two numbers that multiply to negative 18 but add to negative 3. We can list them out if we need to. 1 and 18, 2 and 9, 3 and 6. All those multiply to 18, but I need to figure out, is there some way I can attach a negative to one of those to make it so that when they're combined, the answer is negative 3. It's going to be this guy here. If I were to put it with the 3, negative 3 combined with 6, that would give me a positive 3, and I'm trying to get a negative 3. So even though multiplied I get negative 18, they don't combine. I say combine because people get confused when I'd say add versus subtract. So I just say, just think of it as combine. So if I stick it with the 6, 3 combined with negative 6 is negative 3. 3 times negative 6 is negative 18. So that means that we're going to break apart that negative 3, and we're going to write that with the 3x and a negative 6x. I'm going to go ahead, and put, I'm trying to get that guy out of there. I'm going to go ahead and put the negative 6x first. And I'm just doing that because that seems to like it will go well with the 2 and that the 3 will go well with the 9. So I'm going to have negative 6x plus 3x. Again, if you put them the other way, it probably works. You can give it a try. If it doesn't work, you just go back and swap them. And the way you would know that it's not working is like up in here, how we had this x plus 5. If they don't work, what usually happens is one will say something like x plus 5 and the other one will say x minus 5. You want those to be exactly the same. Okay, that's how you know that it worked. All right, moving right along. Grouping the first two, I have a 2x and x minus 3, right? Plus common factor of 3x and 9, a 3. To get to that 3x, we have an x. Get to that negative 9, I have a 3, so I'm going to do minus 3. Common factor, x minus 3. To get back to x minus 3 times 2x, I'm going to stick in a 2x. And I have x minus 3, and I'm trying to get to 3 times x minus 3, so it's a plus 3. And we're factored completely. Did another one. Good job. Try this one, example 3. X squared minus 4x minus 21. Hit play when you're ready. All right, so the x squared, bring out front, negative 21, a times c. Remember, if it doesn't have a number out front, there really is a little hidden 1. It just looks silly to write it, but you can stick it in if it helps you see it. 1 times negative 21 is negative 21. b, our middle term, is negative 4. So we want two numbers that multiply to negative 21 and add to negative 4. So our factors, we could do 1 and 21. 2 is not going to work. 3 and 7. 4, 5, 6, none of those will work. So we have two options, and we want to pick one that somehow we could get a negative 4 out of it. Second one looks good. If I attach that negative to the 7, 3 combined with negative 7 is negative 4, and 3 times negative 7 is negative 21. So we have found our two terms. So I'll break apart that negative 4x into a 3x minus 7x. Combine the first, factor the first two. They have the x with an x plus 3 minus a 7 times an x plus 3. Bring that common factor of x plus 3 out front. And then we've got the x minus 7. Okay, so don't forget that minus. And we're done. Now, I told you I was going to sneak in two new tiny things. This is the first one I'm going to sneak in. Look at this. Example 3, we're going to do it again. Now, this is a shortcut, okay? The shortcut will only work if that leading coefficient, if this piece out front is 1, okay? Here is the shortcut. Up here in example 3, when we first did it, you see this is the 1, right? Take a look at these numbers that we got here. Do those look familiar in our answer? Do you see those anywhere in our answer? Look at here. There's a positive 3. There's a negative 7. So look at that. Once we got to that point, we could just jump to the shortcut. We wouldn't even need these two lines. Isn't that cool? Okay, so again, it only works if it's 1. Look at our other examples. I'm going to scroll up here. Could we have done the shortcut in example 1? No, because A was 3. Could we have done the shortcut in example 2? No, because A is 2. Can we do it in 3? Yes, because A is 1. If you want to do it the long way, does it work? It does. We did it the long way. It worked. Let's try the shortcut. Here's what the shortcut is you see, oh, it's a 1. Yay, I get to do the shortcut. Okay, so I'm going to actually write that. A equals 1. We can do the shortcut. Yay. Okay, here's the shortcut. So we just write out our parentheses. This is x squared, right? So if you think backwards about FOIL, the first thing that you multiply to get x squared would just be x times x. So that's how you first set it up. Okay, so if you were to do it the shortcut way, you'd be like, yay, it's a 1. I'm going to do the shortcut. So then you write out your parentheses, your x, and then you would go back to here like we did. A times c is 21, negative 21. B is negative 4. You would come up with your list. You would figure out where the negative goes. And then you would just stick those right in there. So plus 3, positive 3, and a negative 7. And look at that, and you're done. Isn't that cool? Okay, example 4. I did a couple of sneaky things in this one. I did. See that y? Does that really matter? No, it just kind of confuses you, right? Just a teensy bit, just kind of confuses your brain because we've only been doing x's. You do it the exact same way. You're just going to write a y. There's a second little sneaky thing that I did in this problem. Do you see it? The second sneaky thing that I did is every other time I have given them to you in descending order. I just gave them to you in the right order. So that meant that it was something squared plus or minus something with the x, and then your whole number was at the end. In order to factor these, you have to make sure that I'm not being sneaky and I gave it to you in the correct order. Okay, so first, try to put it in the correct order. What would I do? It would just be y squared plus 4y. And that negative with the 32, he goes with the 32, so it would be a minus 32. Okay, so now we're in the correct order. Now, what should we do? It's not difference of squares because it's not 2 of them with subtraction. It's not factor by grouping because it's not 4 of them. We don't have to go the long way because even though there's 3 pieces, that part out front, that leading coefficient, that leading number, that's a 1. So that means we can do the shortcut. Okay, so go ahead and hit pause, try to do the shortcut, and come back when you're ready. All right, so shortcut, here we go. We put the parentheses, we put in the y, off to the side, and we say A times C is, let's see, I almost said 4 because I was looking at the original. See how tricky that was? I almost tricked myself. 1 times with the correct order, that C is a negative 32, so minus 32. B is 4. So I need 2 numbers that when I multiply them, I get negative 32. And when I add them together, I get 4. Okay, so I've been brainstorming about this. I'm thinking a negative 4 and an 8. And if you don't see that, remember, you can go back and make that list. Totally fine. So now we have the shortcut. I just stick them in. Minus 4 and then 8. Some people leave it like that. Don't tell me that, okay? That's not good. Make sure you tell me positive 8, just like that. All right, awesome. Moving right along. My next example. Remember, we're going to do 9 of these. We're almost halfway through. Example 5. Now what's going on here? I have 28x to the 6th plus 32x cubed. Wow. You know what? Let's do this first. This is my next tricky thing that I slipped in for today, okay? This a little bit new, but not too bad. Let's just, before we even look at it, before we even do anything, let's see if we can find a greatest common factor. So what do they both have in common? We got some big numbers here, right? The 28 and 32, I'm thinking of 4. Okay, I could pull a 4 out of both of those. How many x's could I pull out of both of those? For some reason, students want to tell me x to the 6th. But if you think about it, I'm going to jot this off to the side just to kind of help. 28 x to the 6th. I'm going to rewrite that as factors of 4 times 7 times 6 x's. You get them all? Got them. I'm going to write 32x cubed as 4 times 8, my 3 x's. So what do these 2 terms have in common? They had that 4, which we agreed on, right? We pulled that out front. Now, how many x's do they have in common? They have 3 of them. So that's why we can pull out x cubed. Some people have to write this out. That's fine. Other people, they look at this and they're just like, well, it's going to be whatever the lowest amount is, because how could they have more than the lowest amount in common? So the lowest x cubes we could pull out of that second one would be the full x cubed, right? So now we have 4x cubed, and we're going to try to figure out what I'm going to stick in here. Okay, so if I have 4x cubed, I'm trying to figure out, if I were to work backwards and multiply, how would I get to 28x to the 6th? Well, that would just be 7. And remember, you add your exponents, so 7x cubed. If you happen to be somebody that writes the side work, a way to check your work is that the 7x cubed, look at it, it's right here, 7x cubed. Isn't that cool? Okay, and then for the second piece, a 4x cubed, to get to 32x cubed, just 8. And again, if you happen to write out your work, you can see it was just the 8 was left over. Can I do anything else? Even though what's in the parentheses is 2 terms, we can't do a difference of squares because it's not subtraction and it's not 2 things that are squared. So we're actually totally done with that problem. All right, number 6. The first thing I want you to do is try to see, is there a greatest common factor? Okay, so when you look at these problems, the first thing I want you to do is see if it's a greatest common factor. And then I want you to work your way through the list, like I've been doing. Is it a difference of squares? Is it 4 terms for factor by grouping? Is it a trinomial with 3 pieces that has the 1 where I can use the shortcut? Or is it a trinomial with the leading coefficient greater than 1 where I have to do it the long way and force it to be 4 terms to do grouping? Okay, so, and start by looking for the greatest common factor. So find the greatest common factor of this one. Go ahead and do that, and then go ahead and hit play. Okay. What'd you come up with? We have a lot going on here, right? So we've got a 12, a 21, and a 24. So let's start working through them with 2. 2 wouldn't work, right? Because that's not going to go into the 21. 3 would work. But is there something bigger? Okay, so don't just stop. When you find one, try to find the greatest common factor. So would 4 work? Nope, wouldn't go into the 21. 5's not going into any of them. 6 won't go into 21. 7 won't go into the 12. 8 won't go into 21. 9 won't go into the 12. 10, nope. 11, nope. 12 also won't go into the 21. So yeah, it looks like we did find the greatest one right off the bat. Awesome. So we got 3. How many x's come out with it though? 3, right? So it's going to be 3x cubed. Because that x cubed on the end, that's our smallest one. So that's the greatest thing they can share, is whatever that smallest one is. And now in parentheses, we'll go ahead and add in what we're going to multiply each of those by, right? How we're going to factor it. So if you didn't do that already, go ahead and hit pause, give it a try, come back when you're ready. So if I have 3x cubed, I'm trying to get to 12x to the 5th. That's going to be a 4x squared. Because 3 times 4 is 12, and I add my exponents when I multiply them. So x cubed times x squared, 3 plus 2 is 5. Minus, to get to 21, I have a 3, I have a 7x. Finally, plus 8. Now this piece in parentheses, sometimes we'll be able to keep factoring it. Okay, so let's see if we can factor this one. Off to the side, it's got 3 terms, leading coefficients greater than 1, so we're going to have to go the long way. A times C, 4 times 8, I get 32, and B is negative 7. So we want 2 numbers that multiply to 32 and add to negative 7. What do you think? It's actually not possible. This one's totally done. If there were 2 numbers, it would work out. We would just keep going and carry that 3x cubed out front. But it looks good the way that it is. If you had originally just been given just this piece with the green and you couldn't factor it, you would tell me that it's prime. Okay, so prime would be that there's no factors that would multiply to that, just like how we have our prime numbers, like how 3, there's no 2 things other than 1 and 3 that multiply together to give you 3. So that means that 3 is prime. So this would be a prime polynomial. But because our original question was all of this, and we did do something to factor it, this one you wouldn't write prime. You would just tell me this is your answer, and that would be awesome. All right, let's do 3 more, okay? Number 7, 5x to the 4th plus 10x cubed minus 120x squared. What should we do first? Try to find the greatest common factor. Because if you right now start doing that whole a times c business of 5 times negative 120, oh my goodness, that's going to be a ton of work. So try to factor out a number first. Okay, and then see what would be left in the parentheses. Go ahead and try it now. All right, we got a 5, 10, and a negative 120. I'm seeing a 5 I can pull out, and an x squared. Now it goes in parentheses. 5x squared, you get to x to the 4th. Thinking that's an x squared. And then plus 2x minus 24. Okay. Now we're going to keep going, right? So let's look at what's in the parentheses. We have a trinomial with a leading coefficient of 1, which means, hey, there's a 1. We can do the shortcut. So a times c would be negative 24. B is 2. Okay, so we want two numbers that multiply to negative 24 and add to 2. Make the list if you need to. If you don't need to, that's awesome too. We could have 6. Let's try it again. There we go. 6 and negative 4, right? Because 6 times negative 4 is negative 24. And 6 combined with negative 4 is positive 2. So what I have to do, this part students forget so much, is bring that 5x squared down for me. He's still part of the answer, okay? And then show me that then you just took this piece here in the parentheses and you kept going. So it's the 5x squared out front, you jump to the shortcut, and you got a plus 6 and a minus 4. Do you think here in my answer it would have mattered if I had put the x minus 4 first and the x plus 6? No, it doesn't matter. Okay, multiplication, order doesn't matter. It just looks pretty to put like that 5x squared out front, because if you were to stick that guy in the middle or at the end, he would need extra parentheses and it would look kind of silly. Okay? All right. Look at this one, number 8. 15x to the 4th minus 39x cubed plus 18x squared. Always try to start by looking for that greatest common factor, because it will make your life so much easier. Because I do not want to multiply 15 times 18, okay? That does not sound like a good time to me. So go ahead and give it a try. Try to solve this one, see how it goes. Come back when you're ready. All right, did you get it? Let's see. I went with a 3x squared. That left me with a 5x squared minus 13x plus 6. Off to the side, let's do our a times c. 5 and 6, I get 30 because we're just trying to factor what's just in the parentheses, right? B is negative 13. What two numbers did you get? Two things that multiply to 30 but add to negative 13? How about a negative 10 and negative 3? And again, if you don't see that, make your list, totally fine. Don't forget, bring down that 3x squared out front, because what we're doing is we're simplifying, or we're factoring what's in the parentheses, right? That leading coefficient is not 1, so we can't jump to the shortcut. We have to go the long way. So I'm going to put in the 5x squared and the plus 6 on the end. I'm going to break apart that middle term, negative 13x. I'm going to rewrite as negative 10x. I'm putting the 10 first just because I think it will work out nicely with the 5, and then the 3 will work out pretty with the 6. Okay, so another way to write negative 13x is a minus 10x minus 3x. All right, again, that 3x squared, he's just hanging out. Now, we're going to have to do factor by grouping. So these two guys and these two guys. You can do a lot of parentheses if you want. It's going to look kind of messy. A lot of people at this point, they like to do brackets. They work exactly the same as parentheses, but it kind of helps your eyes and your brain see it better. There's like super parentheses. Okay, so there's my super parentheses. And when I factor these first two terms, I have a 5x times an x minus 2. Minus the second 2, I have a 3 with an x minus 2. Bring that 3x squared down. What we have in common is that x minus 2, leaving us with x minus 2 to get back to 5x times x minus 2 would be a 5x. And an x minus 2 times, to get to this negative 3 times x minus 2, there's our negative 3. And can we factor anything else? We cannot. We're totally done. Let's do one more and then we're out of here for today, okay? This one might look a little bit trickier because I snuck in an extra variable. Okay, there's 2 variables. What do you think we should do? All we're going to do is we're going to consider this exactly the same as we did our other ones, where we had A is what's out front. So what's A? A is 1, which is our shortcut, right? So we know we're going to use our shortcut for sure. B is negative 14. And C is 48. So off to the side, if I do A times C, 1 times 48 is 48. B is negative 14. Now I want 2 numbers that multiply to 48, but combine to negative 14. Okay, so you can list them out if you need to, or if you see it, negative 6 and negative 8. Those multiply to positive 48, but combine together to be negative 14. So we can jump to our shortcut. Here's my parentheses. Remember, put the x there so you can get to that x squared, right? And at the end, look at this. You're also going to have to get to a y squared. So I'm going to tack on that y here. Now my shortcut, so that I could just put in the minus 6, and it's going to be minus 6y, and then this minus 8, so minus 8y. Okay, so that y, even though he's showing up at the end, he's kind of just hanging out. He's kind of just tagging along. If you want, what's awesome about this whole unit of factoring is that you can go back and you can check your work. So if you want to do this on any of them, if you have time, I would definitely recommend it. Let's go back and check. And the way that you're going to check it is just by taking your answer. I'm just going to rewrite this real quick. And you're going to do what we did in unit 1 of actually multiplying it out. And hopefully you get the original problem. Okay, so this is the check. So we do first, we get x squared. Outer, we'd get a minus 8xy, right? Inner, we would get a minus 6xy. And finally at the end, we get a plus 48y squared. X squared, we have a minus 8xy minus another 6xy, we would get minus 14xy's. Plus a 48y squared. And that matches our original problem, so we factored it correctly. All right, very cool. So that is it for the videos for a couple of days. So the next 3 days, again, are going to be activities I'm going to be posting online, some worksheets to go through. Please do them. Please ask me questions. I love your questions, okay? So making mistakes, asking questions, that's where you're going to learn. And I really, really, really want to stress how important these last 2 videos were today and yesterday. All right, so if you need to, watch them as many times as you need to. Ask me questions. We've also got the Mark tutoring online can help you out, all that good stuff. All right, I hope you have an awesome day. I will be posting those things on Canvas for you to check out. All right, talk to you later. Bye.